Welcome to the Solving Equations with Roots and Radicals episode of Mrs. Mulvey's Math Movies. Before we start talking about solving equations with roots and radicals, let's do a quick review of what roots and radicals are. So basically, when I talk about radical, I'm really referring to this symbol that tells you what sort of root you're looking at for a value. For example, if we talk about the square root of 9, that has a value of either positive 3 or negative 3. And so that's the radical symbol. The root is the square root. When nothing's there, a 2 is implied. And it means to find the number that you multiply by itself 2 times to get what's underneath here. And in this case, either positive 3 times positive 3 gets us 9, or negative 3 times negative 3 gets us 9. So they're both square roots of 9. I can have a cube root. Let's look at the cube root of 8. So this is the radical symbol. This tells me what sort of root we're looking at. And so in this case, to look at the third root of 8, I'm looking for the number that I would multiply by itself 3 times to get an answer of 8. And in this case, it's 2. 2 times 2 times 2 gets me 8. So that means that the cube root of 8, or the third root, you can say it either way, I prefer cube root, equals 2. And that's because 2 times 2 times 2 equals 8. Notice, when you have an even value here, and by the way, the technical name for this is the index. When I have an even index, you have to consider that your root could be positive or negative. If you have an odd index, the sign of the root will match what's underneath here. So cube root of 8 is 2, because positive 2 times positive 2 times positive 2 gets me positive 8. I can take a cube root of a negative number, and in this case it would be negative 2, because negative 2 times negative 2 times negative 2 equals negative 8. So there's the quick recap. I know we've talked about this already, but there's the quick recap just to remind you. So let's actually use this to solve equations now. So when you have equations that look like this, you've learned a couple different ways to solve an equation like that. We're going to look at one more method. Because I have just a variable with a power, and I don't have a linear term, notice I have an x squared but no x. What you can do when you have that situation, when you have a single variable within your equation, is you can isolate the variable and then use roots to solve. For example, right here, since I have 100 divided by x squared, since I have 100 times x squared, I'm going to divide both sides by 100. And when I do that, I get x squared equals 4. If I take the square root of x squared, that leaves me with x. Now technically it's positive or negative x, but I'm going to take the positive or negative on the right side here. When I take the square root of 4, that gets me positive or negative 2. And so my value for x could be positive 2, it could be negative 2. Either one, when I put it into the original equation, I will get a true statement. In this case, when I fill in the positive 2, I end up with 400. And when I fill in the negative 2, I end up with 400. Because negative 2 squared, that's negative 2 times negative 2, that's positive 4. And 100 times 4 is 400. So both of these answers check out. So your goal really, when you're solving these types of equations, is to isolate the variable and then take the root. Now remember, taking a root might involve a fraction. Let's take a look at what I mean. I'm going to go back to our 100x squared, but instead of equals 400, I'm going to make it equal to 25. So first step still the same. I'm still going to divide by 100 to isolate that x squared. And when I do that, what I want you to do is don't change this to a decimal, simplify. 25 1/100ths, I can divide both the numerator and the denominator of that by 25, and when I do that I end up with 1/4. So now I'm going to again take the root, in this case it's a square root. This index should match your exponent there. Take the square root here as well, so over here I'm left with x. Remember, when you take the square root of a fraction, that's just the square root of the numerator and the square root of the denominator. So in this case, it's positive or negative, and the square root of 1 is 1, square root of 4 is 2. And so my answers are positive or negative 1/2. Let's look at one that involves a different index. Let's look at this one. 6x cubed equals negative 48. Steps are still the same. First thing I'm going to do is isolate the variable. I'm going to divide both sides by 6 here. You get x cubed. Negative 48 divided by 6, that's negative 8. Then I'm going to take the root. Only this time, because I have an exponent of 3, I am going to take the third root, or otherwise known as cube root. Here, I end up with x. And then the cube root of negative 8, that's the number that I multiply by itself 3 times to get negative 8. That equals negative 2. Notice when you have an odd index here, your answer sign will match the sign of the base. And so the only solution for that equation is negative 2. So let's look at one where it takes a little bit more work to isolate the variable. Let's take a look at this one. 64y cubed plus 125 equals 0. So just doing simple division here isn't going to isolate the variable. I have a two-step process, just like you would solve this equation if this was a y instead of a y cubed. The first thing I'm going to do is I'm going to subtract the 125 to get it over to the right side of the equation, or really just to get rid of it on the left side. Once I've done that, now I can divide by 64. And that negative 125 over 64 cannot, oops, not 24, 64, cannot be simplified. There's no common factor besides 1 of 125 and 64, so I just leave it alone. Now I'm going to take a cube root. Again, my answer is going to be negative because of the negative sign underneath there. And the cube root of 125, that's the number that I multiply by itself 3 times to get 125, that's 5. Cube root of 64, that's 4. And so my answer is negative 5/4. Let's look at one that has an even higher root, or I should say even larger index. I'm going to look at 2x to the 5th minus 64 equals 0. So again, my first step is to isolate the variable expression. In this case, I need to add 64 onto both sides. And when I do that, I get 2x to the 5th equals 64. Then I divide by 2. And when I do that, I get x to the 5th equals 32. Now I need to take the root. Because I have an x to the 5th, I am going to take a 5th root of both sides of my equation. And because this is an odd index, the sign of my answer will match the sign of this base. And in this case, it's positive, so my answer is going to be positive. So here I end up with x. And here, the fifth root of 32, that's 2. Because 2 multiplied by itself 5 times gets me 32. So that's it. Let me know if you have questions. But that ends this edition of Mrs. Mulvey's Math Movies. Have a good day. Bye-bye.